start with Professor Ogawa, who's the president of ACAP, to introduce to you the ACAP and also the Reinventing University. Ogawa, please.
Hello, good morning and good afternoon and good evening. And I'm Takeo Ogawa, president of the Active Aging Consortium in Asia Pacific. At first, I would like to express my heartfelt gratitude to the people involved in the Center for International Collaborations of Innovations and Safety for Aging CICASA at the Faculty of Health, Tamasato University, who helped prepare today's webinars. Thank you very much. The Active Aging Consortium in Asia Pacific was established in Fukuoka City 20 years ago. At the beginning, 10 researchers and regional leaders who shared these missions in 4 regions, Japan, Hawaii, South Korea, and China, and has now become a network of 1,400 mailing lists in more than 40 countries. ACAP is a voluntary information sharing body open to people of all ages, abilities, and disciplines. Members are gerontologists, geriatricians, and educators globally, primarily in the Asia-Pacific regions, dedicated to the empowering older adults to maintain their physical, social, psychological, civic, economic, and environmental fitness so that they can continue to contribute to their families, their communities, and society at large. Of course, active aging cannot be achieved through individual effort only. Active aging cannot be achieved without social effort. Therefore, we are holding monthly webinars and bulletins for sharing our knowledge and skills toward active aging societies. At the last month, we had this webinar titles Navigating Aging in East Asia, Insight from South Korea, Japan, and Taiwan. Next month, we will not hold webinar, but we will hold an on-site meeting in Bangkok at the Akai ACAP side meetings on PMAC in 26 January 2026. We will also visit Tamasato University and discuss our future risk issues. Anyway, in this month, we will share the interesting issues, healthy aging at home. This session is promoted by the Inventing University team, Tamasato University. Then I will introduce the leaders of this project, Katya Ivanovich. She is a leaders of this the Inventing University project. Okay, this is the time for Katya, please.
Thank you so much, Professor Takeo Ogawa, for your kind introduction to me. And good morning, good afternoon, or good evening to all. And I'm very happy to share our overview of the project as well. So I will give you the overview introduction. This is our webinar today is a part of our project Reinventing University 2025, which support by Higher Education Ministry. And the theme of the project is creating healthy environments and promoting health behaviors for quality aging. Yep, and the objective of the whole project, we have various activities that we continue activities through the years, but it's still going on. First one is to develop the knowledge and innovations that improve environments, manage health impacts, and promote healthy behavior for the older adults. Strengthen collaboration and capacity building among all sectors to co-create innovations for elderly-friendly environments and health promotion. And the last one is very important, that the platform today is really fit for this one. That's establish national and international collaborations to elevate care standards. Yes, and this is our core team, and I'm as the PI, and cannot make it happen without the whole team. That we are all in the Faculty of Public Health with different expertise that we join together, yes, to come up with somehow to develop the knowledge and the innovations as well. And we have our partner from Asian Institute of Technology as well, Dr. Adison, who joined us at the beginning. And of course, we work together with CCSA Center, the Center of International Collaboration of Innovation and Safety for Aging, leading by Dr. Kaeson, and she provides the platform here today as well. And actually, the last activity we have been developed the innovations among the students and researchers, and we will have the pitching at the conference on the 30th of the January 2026. We joined together with LiveAnet from Singapore to organize this event, and we have our important speaker, the keynote speaker, Professor Takeo Okawa, to join us as well. And we have special talk from Professor Dr. Eve from UK. This is she is also from ACAP as well. She will talk about the reimaging care, building resilience and inclusive communities. And this is we welcome to you all to join us this event, and also we will have the following webinars, episode 2 and 3, and we will announce on the website also. And I'm really happy to invite all of you to join us. And this is my contact. And okay, from today's webinar, this is the first episode for us. And we have a key 3 speakers that will share the knowledge and research as well. Now, I would like to give a hands-on to Dr. Thongchai Khanapkaew. He is the MC for today. Yes, please, Dr. Thongchai, and thank you.
Thank you very
Thank you,
much,
Khan.
Dr. Katia, for sharing the information about the project, and also passing the role of MC to me. So I have to say again, good morning, everyone. So today we welcome you to our webinar of Reinventing University, and also with the ACAP and CSA, right? Yeah, and then this is under the topics of the today about health, aging at home, innovation, and environment for independent living. And today's session going to be our first episode. So we call this one like episode 1. So we with the topics of smart health and assistive system for aging at homes. So in our today's seminar, so we explore how technology, data, and designs can support older adults to live safely, independently, and with the better quality of life at home. So our speaker today are, I think, the young generations, even myself, but we are prepared for the next future that going to coming soon, that we have to stay like independently and safely at home. So today we honor to have the 3 distinguished speakers whose work covered the smart sensor for the air quality, artificial intelligence, and ergonomic design. So I hope that this interdisciplinary of our knowledge of our speaker can highlight how innovation and evidence-based design can directly improve the elderly health and safety. So let me start introduce our first speaker. So our first speaker is Dr. Adison Lersin Saptavi, the Director of Internet Education and Research Laboratory, or we call Interlab, at the Asian Institute of Technology. So good morning, Dr. Adison. Can you say something so people can notice that where are you? Yes.
Hi, good morning ครับ สวัสดีครับ
Okay.
สวัสดีครับ สวัสดีครับ
สวัสดีครับ Good morning. So today, Dr. Edison will present on the topic of smart aging with good air technology. So his work will focus on how indoor air quality data and smart technology can help to protect human health. So particularly today, we focus on the elderly. And our second speaker, we have Dr. Jenipat Moonlinta. He's the senior research associate at the AI Center, also from the Asian Institute of Technology. สวัสดีครับ Dr. Jenny.
สวัสดีครับ Morning ครับ everyone.
Okay. So his talk is about the smart fall detection for healthy aging at home. So from his presentation, we demonstrate how AI-based system can detect the falls in the real home environment and support timely assistance for older adults. And our last speaker, we have Dr. Thirapan Gaudop. So he is assistant professor at the Faculty of Public Health, Thammasat University. And also he is head of the research unit in occupational and ergonomics. So good morning, Dr. Thirapan.
Morning,
สวัสดีครับ
everyone. Thank you to share and join us today.
Yeah, thank you very much. And Dr. Thirapan will present on the application of anthropometric data for elderly-friendly home and facility design. So his work will use the evidence-based design from Thailand, and he will show how anthropometric data can improve daily life safety for the elder adults at home. So I think we are now all getting to know our speaker today and the themes that we have that could be starting from something about the environmental condition, air quality, and then we go through the fall detection, and the last one will be how to design the home to fit for the elder adults. So before we begin the talks, I would like to mention that we will have around 15 minutes for the speakers, plus or minus, maybe something. It depends on the story. And then after that, after all completed the presentation, we will have question and answer. So actually, along the presentation, if you have the answer, you have question, you can put it in the text chat in the Zoom link. Or at the end of the presentation, you can ask by using verbally by turn on your microphone. You are all welcome for that. So now I think we begin with our first speaker to share his knowledge and experience in working on the smart sensor and technology. So please welcome Dr. Edison.
ครับ สวัสดีครับ Good morning. Let me try to share my screen. You should see the blue screen, right? Now let me try to share.
Oh, okay. Yeah, exactly. Yeah, your full screen now.
Okay. Okay, does that work? Okay, thank you. So, okay, let me start. I think we have a very short minute, right, for 15 minutes. So first of all, thank you all the TU teams and then all the CICAs that inviting me for sharing my knowledge and sharing our expertise about our activity in the lab. So the topic that have been assigned today is about the aging, right? But frankly speaking, I'm mostly my work we have been working on internet connectivities, IoTs, and recently we are moving to the air pollution, right? So today I will try to matching this kind of three topic that I'm working on with the aging technology. So the topic that I kind of inventing is like a smart aging with a good air technology. Okay, so let me start with when I get the assignment from Dr. Thongchai about the aging society, like first of all, I ran into the definition first, like what kind of aging society means. So then I got some definition from the WHO. Then they define the aging society at the three level. So the first one is aging society. So that means like if a population of our nations like been beyond 10% of population is being has the people that more than age 60, right? So we can counting on the aging society. And for the second level, we have like if the population of age 60 plus people more than 20%, we can consider as a complete age society. And the last one, like more critical one, more is like super age society when we had 20% of the population have been mixing with the 55 years old people. Like that's kind of definition of the WHO. And then looking to the Thailand situations right now, so the data that I got is from the Thai statistics, right, as of 2024. So now the population of the people who have 60 plus in Thailand is nearly is above 14 million already, which can be count on 20%. That means Thailand now, we have been completely entering to the complete age society at certain level. And then if we look into the past 10-year data as well, so we are moving so fast from aging society and to the complete age society. That means that in the next coming year, like we're gonna turn into the super age society. And that as we know, right, from the news and then from I think you are working on this kind of area, right? If we are turning to the super age society, right? So a lot of problems, a lot of issue, a lot of preparation that we have to think of, like economics or health, and also reinventing the environment, right, to fit in for those elderly people. Okay, so let's move on to the second statistics that I have. So then I'm looking around to the kind of a problem that can be linking to the elderly people, and then I found that the housing can be the issue, right? Making the environment to be fitting to the elderly people can be a challenging for the upcoming year or the next 10 years, right? So this is statistic from the Thai Health Promotion Foundation or SOSOSO. This is kind of a Thai authority working on the health or public health. So the SOSOSO listing about the ranking the top 10 provinces in Thailand, right? And then try to linking to the housing or vulnerabilities. And then they have 5 key issues that may concern. The first one, like how many percentage of elderly people are living alone. So you can see that on the first row, the first columns here. Yeah, the top rank is in Pachimuri. So that's about 21%. That means like 20%. If you look into the 100 people of the elderly people in Pachimuri, right, 20 of them are living alone. That's quite risky. And then second column is about the ratio between like elderly people that need the assistance or need the care. And then we found that Sakonnakhon is the top ranked one, 18%. That is quite high number. And the thing that I want to discuss today is about the third one, the third column that I highlight here in the middle. So this factor is related to how elderly people are living at home, and then what kind of environment is inappropriate or not. And we found that if you look into the top ranks of provinces, right, it's rarely from is all of them are above 89%, which is very super high. So that means the elderly people who live in these top 10 provinces, right, most of them are living in appropriate housing. So the housing that they live, the residents that they live, are not being designed for them. So that is kind of the critical issue that we try to tackle with. And then I think like for me, I'll be focusing on the air pollution, and then the second speaker I think we're talking about the fall detections, right? And then the last one, most of us will be talking about how to build the environment to fit in for these kind of people. And hopefully the solution we talk today can try to reduce this number and then try to solve this problem in the long term. Okay, let's back to the topics that I'm working on is about the air pollution, right? So I found this one from the internet, and also I get the help from the AIs as well, like talking about what kind of the indoor air pollution that can be seen, right? The left hand side is kind of what we've seen, right? So we push our parents or our parent generation, elder people, right, to live in the really nice places like in the condominiums. So nowadays we have many places to try to build like that, right? So by vicinity, right, it looks nice, clean, sleek, but actually there are something that we cannot see that I call it like invisible threats, right, at home. So and that related to the air pollution, right? So even though in the clean proper air, clean proper environment, right, we still have a lot of pollution that we cannot see, and that's we try to exploring them today, and then hopefully open this discussion for this community, and then we can try to working together in this topic. So, and then what could be the bad guys or invisible guy that can be detected inside our house or inside our parent house. But yeah, first of all, yeah, it can be particulate matter. I think this is very well known. Millions, right? Everyone knows about PM2.5 particulate matter. So this kind of the air pollution is very small, fine grains, the size like 2.5 micrograms. The elderly people can breathing directly, right? And that can be affect to lung or COPD disease or asthma, heart conditions, and also like strokes as well if you breathing too much, right? And thankfully now today, the technology that we have right now, there are so many technology that been, and then one of them is sensor technology. If you look into like about 20 years back, right? Sensor, when we talk about the sensor, right, we are thinking about something really expensive and really high end, really like niche market, right? But now today, those kind of sensor have been cheaper and cheaper and cheaper. So from like 100,000 baht, and then now we can reduce the price from the sensor to be like a hundred, like 400-500. We can get quite acceptable sensor acceptable sensor, and then with 1,000 baht. So you can get a very high accuracy to detect the PM2.5. And the technology behind those kind of sensor is based on we call that light scattering. The light scattering that is quite been well developed in the field. I might not go to the detail about how the light scattering working on, but I just try to explore that technology that we're using right now. And second one is the second killer is called the carbon monoxide. This is really quite dangerous because the properties of the CO, like carbon monoxide, like we cannot see them, we cannot smell it as well. So that, and then when we start to feel it, right? So that means like the concentration or the level is really passing to the danger level already. So that's kind of that is quite a need that we should have some technology that could be detect or to making some kind of early warning, right? And that sensor come to the place. So the technology that we behind the scene of the CO sensor is like electrochemical cells or metal oxide or MOS. This is been quite well developed in the past, and then the technology is still going on as well. And then nowadays, this kind of sensor have been cheaper and cheaper as well. And hopefully, like we could making kind of this sensor to be every home eventually for the elderly home that could be making a lot of helpful. And then I might not go to all of them because I think we have quite unlimited time, right? So there another one is CO2, carbon dioxide, that can be linking to some kind of dizziness or headache. And then if the elderly people just have consumed more CO2, right, it can link to kind of falling down as well. So that can be kind of warning sign that we can be protected. And VOC, this is volatile organic compounds came from like some kind of spray. So they have some gases inside, right? So that kind of making the leaks. In terms of humidity, seem to be fine, but actually, if you are talking to the Thailand conditions, or we're living in very hot countries, high temperatures, high humidity, can make a lot of fatigue, can make a lot of tired to the elderly people as well, and that can make some kind of consequence like stroke or some kind of falling down. That can be the consequent part that we can fall from the factor from the temperature and humidity. Next one. Then how we could turn those kind of environment to be more digital, and then we can be more real-time monitoring, right? So the one solution that we can keep talking and then working on is about IoT, Internet of Things. The sensor that I mentioned before, it's just about the analog sensors, right? Those things cannot be seen by the computers or cannot be seen by the digital format. So we need some kind of a hero to connect with it. The core part of that is called the Internet of Things. And then you can see that in the middle, right, we have microcontroller or gateway, right? So let's think about this is kind of a mini computer, a small computer that we can write the programs to read the data from all those sensors. And then we can write another part of program to send the data to the internet or to the cloud. That can be making the end-to-end solution for the air pollution monitoring, right? So the communication part, there are so many technologies, right? But the most technology that we use in this wireless protocol, because you can send the data to the wireless communication. The quite common one is Wi-Fi. I think everyone knows about this one. 6B Bluetooth. If you don't know that, it's like a near the close connections, right? You can like similar to the Bluetooth, when you can send the data to the mobile phone and so on. LoRaWAN, it can be used for some kind of long range communication. If we talk about in the hospitals, or that you have the vast areas of and then we cannot provide like Wi-Fi connectivity there. So we can use one Wi-Fi, one LoRa gateway, right, and then cover all the area. That's a kind of technology that we use, like short range, middle range, and long range. And then on the cloud, we can we have an option to setting up the cloud, like the server, right? So we can set up our own server there. But if you don't been hectic or been headache for setting up, we can use another commercial platform like Amazon AWS, Microsoft Azure, ThinkSpeak. This is kind of open source, and then you can pay for them as well to facilitate, and you got like a lot of resources to helping you to set up this kind of system. So let's move on. So this is kind of some use cases or some example. Maybe it's not linked to the elderly people yet, but this is kind of experience that we have been done to the Interlab. Right? So at Interlab, so we are building a platform called the CHMON, or in Thai we call the Watfun.Thai. The platform is including the sensors and the microcomputers, the IoT solutions, and that we can have a plug-in sensor, like we can add like the many sensors that we can. One application that we have been measurement that we've been have been done before in the past, right? During the COVID times, so we started to come back, right, about 2021, and then we have the question that it's safe to be let the staff to come into the lab, right? So that's why we're starting to like, so we should do like measuring the CO2, because the CO2 are linking to some kind of, is a good condition for ventilation or not. So if you've been a lot of people like sitting to it's a high concentration of CO2, right, it can be linking to like you are risky for infection for the COVID or another kind of disease as well. So this is a very simple example that we do. Like we just set up like the sensor in every room in our lab, and then we try to vary like measuring the CO2 in real time, and also we try to counting on the person, the staff who live in the office as well. So we found that when on the in the first graph here, so the light graph showing the concentration, the real time concentration of CO2, and then the bar chart here is showing the numbers of the people who live in the office, right? So we run the measurement about 5-6 days. And then not surprisingly, we found that when the room is empty, like we have in the forecast about 400 ppms. And then when we are just one person stay in the office, right, the average CO2 is increasing about 500 ppms. And then with 2 and 3, just reaching up to about 900 ppm. If you look into definitions, right, so we still safe, because in the definition they say like if the CO2 level is still below 1000 ppm, right? So it's kind of indicate that the environment that we say is quite safe. But however, if we think about like thinking more dense and more people are living like in hospitals or elderly care, right? So they're in one room, so you might have like 10, 20, right? That kind of CO2 can be escalate that, and then it can link to some kind of this is kind of symptom, the drowsiness, discomfort, or headaches and dizziness, right? So this kind of the warning that we should be seen before should be seen in advance. And the next one, this is my curiosities as well. This is measurement. This is in my condominiums at home. So as we know now, we are moving to the smart living society. Right? I think most of us are living have the experience living in condominium. So the problem that condominium that we have, like, so this is the most common layout, like the studio layout. Right? We have a big one room that can be divided in 2 parts. This is like a main room, and this is like the kitchen room. So when we stay in a condominium, right, I don't think that everyone open the door. Right? We always close the door, and then we also close the windows as well, because we want to live in the air conditions. Right? It's kind of typical scene that we use. And so what the measurement that I did. So normally I came home around like 8-9 p.m. and then about 10 p.m. I start to closing the windows and then turn on the air condition. As you can see, this is spotting that like this is the time that I start my aircon and then close the windows. You can see that the CO2 is been increasing, and then I was surprising like, okay, at my room, I always clean the rooms and then really neat and really new condos. So the CO2 level is reaching up to 1,800 almost every day, almost every night. So, and this is the peak because the peak is about 7 a.m. Because 7 a.m. is my 6 a.m. and 7 a.m. is my waking up time. And then I start to turn off the aircon and then turn on open the window, and that CO2 is being kind of declined. So as you can see, like this is kind of just me and then one person living in this kind of the environment that we live today. So the CO2 level is been that we cannot see, like if we don't try to do some kind of measurements like that. And that's the some kind of the message that I want to put out there for open, right? So thinking about the elderly people, right? This 1,800 ppm is really risky for them, to link to the headaches or kind of a link to the falling down. Okay, next one. Maybe it's not much related to the elderly people, but this is kind of some project that we have been done, and then we still keep going on as well. So this is kind of we do the measurement of the PM 2.5 exposure to tracking the activity for the outdoor worker. So we can we building the very small portable sensors, right? With we have been support from the Grab rider, so we managed to put our sensor under their helmet. And then in second project, so we are also building. This is my my notes as well. I've been devote myself to be part of experiments as well. So the idea was we want to try to track our activities, that how much exposure that we been consumed every day, right? Especially for the PM 2.5, because the data that we can see from the public information like PCD or airflow types, right? That might not be reflected to the actual one. And that is some example that we have, like, so we see that so many like the PM, the levels have been so high, and then we calculate the leaks of the lighters. So we found out most of them are 60%, 6 of the 10 are being considered as a very high leaks in terms of when calculation the hazard questions. I think I'm running out of the time, so I try to wrapping up in the last slide here. So so what I try to say, the message I want to say from now, right? So we have the system already, IoT, a low cost sensor. Those kind of things can be producing a lot of data. So now it's the time to how can we benefit from those data, right? So I put my last slide into like we want to turning the data into some kind of smart and the preventive actions. Right? So the first step that I think we already succeed in this one, right? Data analytics. So we have the data. We can write some simple equation or some simple rules, like if some kind of, for example, the CO2 level, if reaching to 1,000 ppm, so we can marking on alert or warning that we have to do something. And as a second step, so we can link to another system, like the warning system, like Line, SMS, notification, email. Like when this kind of the threshold has been reaching up, so we can send some kind of message to the key person, like families or the close emergency contacts that can be running to the elderly people to help them. And then the last one that we've been just started, and then we hopefully with the partnership here, we could build something more, something we call the smart aging, right? So I'm thinking about the smart home automations, right? So once we got the alert, right? So we do some kind of active action. The simple one that I can thinking about is like when the PM 2.5 is so high, so we can link to like the air purifiers, right, in the system, and then we can turn on the air purifier automatically. And the more advanced is that, like we can think about like building door or window to be flexible, to be turning on and turning off, as well to be controls the room temperatures, or even though like pushing the good air into the house. That can be one of them that you can be think about as well. So I think I try to keep my time at 10 minutes, and then so, oh no, it's between 20 minutes already. I think it's been. So yeah, okay. Thank you very much, and then I will keep the discussion open, and then we can talk later. Sorry for the time.
Oh, okay, that never mind, Dr. Edison. That very interesting information that we got from you. So actually, the question Q&A we put after all the three presenters, then we come back again. Okay, so because of the time, let's me move to another speaker that we have, Dr. Jetnipat. that going to present us how to detect how to do fall detection for the elder people that stay at home. Okay.
Good morning, everyone. Can you see my slide?
Yes, it's full screen already. Yeah, exactly.
Okay, thank you. So it's honor to be here as a part of the webinar, and thank you very much for inviting me for sharing the experience of our research and development in developing the fall detection. So today's topic is about about the smart fall detection for healthy aging at home. So my name is Jenipat Purinta from the Asian Institute of Technology from AI Center. So first of all, I would like to acknowledge our donor, the NBTC, who give our research and development fund throughout these 2 phases. And also we have the team member, Professor Matthew Daly and Professor Mongkol Ekpanyapong is a principal investigator for the research on both phases. And the team from Mahidol University, Ajahn Sunyi and Ajahn Lungtiwa, from the Faculty of Physical Therapy, and also the Khunipa Srichang from the Department of Disease Control. So without them, without their help, without their support, so we cannot run this project smoothly. And also the Rajpipat Hospital as well. Okay, let's get started with the big picture of the fall situation in Thailand. So this is the survey report by the Public Health. So they did the survey on the elders with about 10,000 elders aged over than 60%, and they report that about 7.98% fall in the past 6 months. And with this group, about half of them got injured. And from the injured elders, they went to the hospital, about 53%, and the rest did not go to the hospital. And then from this group who went to hospital were taken, about 83% were taken to the hospital by the relative or those who witnessed in the incident. And about 16% were taken to the hospital by the emergency service, the 1669 service in Thailand is the emergency service. So what this data tell us, so it means that it implies that the fault can be happen with the elders, and it's possible. Even we think that it may not possible, it may happen with the elders. And why do fall matter? Because the fall can lead to the cause of the injury amongst the older adults, and it also can result in the hospitalization, disability, or loss of independence. So from the same report, they also report that about 20% of the injured elders from the fall experience the anxiety and fear of falling again, resulting in reducing the daily functioning. And what about our system? What is the fall detection system? So for the fall detection system that we have been developed and working on, we use a fixed camera, the normal CCTV camera, and we use the video stream from the CCTV as an input to the system. And we try to observe the movement pattern of each person appearing in the scene and try to detect whether there is a fall or not. So if we detect the fall, we send the alert through the line notification to the family member or the caregivers. And the simple flow starts from the camera, and then we have the AI to do the movement analysis to detect the fall and other activity as well. And then, if we detect the fall, we send the alert. So this is how the system works. So, and why is the fall detection hard in real homes? So on the figure here is our data set that we collect in lab. So you may see that normal activity can resemble the falls, like sitting down or lying down. Sometimes some activity may look like the fall, right? And in the home environment, we have complex scenes, like we have the furniture or some occlusion or some lighting condition change. And people may move differently, with walking speed, turning, and walking age. And so that's why that real home are very different and very different from the laboratory setting. And in our research project, I would say that we separate it into, like, we have two phases. The first phase, we would like to have the pre-fall detection system, which we call the elder care phase 1. In this first phase, we study the walking pattern in the controlled environment. So if you look at the left figure here, we got the help from the Ajahn Suni and Ajahn Uhiwa from Mahidol University to help and our team to collect the data from the elders, between elders who has the fall experience and never fall before, and we attach the beacon sensor on the body to get the three-dimensional data of the movement of the body. And then we, at the same time, we collect the video and we use this video to extract the skeleton from the video and try to see whether we can detect that difference between follower and non-follower from the camera or not. But it turned out that the difference of walking pose between follower and non-follower are very subtle. The camera cannot extract those detail level. So it turned out that from this first phase, even though we cannot have a pre-fall detection, but we can classify the stable movement and unstable movement, and also we also do the fall detection as well. So we conclude that the pre-fall detection using the camera alone is very challenging. So from the first phase, we extend our project to the second phase. So from the early prediction to reliable detection in the second phase. So this is the, we focus on reliable fall detection and design for real home and fewer false alert. This figure show the way we collect the data set in our lab by ask our team member, our volunteers, to perform by the normal activity life. We set up about 8 cameras in the room and record any possible views that may use for the real deployment, and we collect the data. So we separate into the normal user and the wheelchair user as well. So once we have the model, we train our model, develop the system, and we deploy. But from our first deployment, we found that we have a very high false detection rate on fall, about 98.01%. So we trying to check that, and we noticed that, okay, there is some behavior like lying down on the floor or lying down on the sofa or the couch that considered as a fall. So we have to improve our system. So by having a more realistic daily activity data and more detailed activity data labeling and clear separation between the false and normal activities. So with this better data leads to more reliable the AI model that we can predict the fall. And we also need to adjust our algorithm and our system to be able to run in real time and still keep the high accuracy. And we expand our deployment from 2 house to 10 house. So on the left-hand side here, I show the statistic along with the activity type that we can classify. So there will be jump, run, reach, lying down, lie down, fall, and unstable, bend, getting up, sitting down, sit activity, sit, walk, and stand with some activity, and stand. So this is the list of the activity that our AI model can predict. So after we adjust the algorithm and deploy and evaluate again, we can see that the system improve and we can reduce the false detection rate on the fall about to the 7.75%. Okay, this is the demonstration of with how our system works. So you can see that we have the people detection and tracking. So you see that each one we have like the activity type, and then try to detect the fall. And you may notice that the fall happened in a very short period. So you see that just only less than 1 second, it appears as a fall. Okay, let me play the video again, just in case you cannot see what is going on. Yeah, this camera we process all together at the same time, so our system can run in like real time, and when the fall happen, we can detect like almost immediately. Okay, this one. And if we look at the capture frame, so this one showed that I try to capture from that demo video and show that okay, we can detect the fall from each camera view, but you may see that this one is not correctly classified as a fall. So that is what we have, that error. And this is the second fall, right? This our lab member simulate the fall, but this time is from this camera, it like have the unstable, it predict as unstable instead of the fall. But the rest is working fine. Okay. Another challenge thing is that when we deploy the system, the fall event is not happen frequently. It's a rare event. So how do we evaluate the system? So we ask the 10 volunteers to simulate the fall, but this group of 10 volunteers is not the same as we collect in the lab, and we ask them to do at the home. So with this simulate fall, we got about in total almost 600 times, 596 times, and we can detect 468 times out of that. And we still have some misdetection, as you may see from the demo video. And in terms of the accuracy, we can achieve about 87.9%, but still have the misdetection rate about 21.5%. So this is the current performance of the system. We can detect most of fall events, but some fall are still missed and can operate in real home and real times. And for the public health framing, the system is ready and useful for reducing the risk, and even it's not perfect. And why it matter for the public health? Because if we can detect the fall quickly, we can have a faster emergency response, and we may reduce the injury severity, and also support the aging in place policy and support the caregiver or physical therapist or the doctor. So I think, yes, that's all for my presentation today.
Yes, thank you very much, Dr. Jedipat. I think it's very interesting, particularly for the pre-fall detection that we're gonna have in the future. Even you said that it's challenging, but we're waiting for that. So next, we move to Dr. Thirapan. So for the two presenter, we see how the Internet of Things or wireless technology can help us assist us in the home. So we are now moved to the how we can design our facility or home to fit with the elder people. So Dr. Thirapan, if you are ready, so you can give the talk.
Okay. I will be talking about on the topic application of anthropometry data for elderly friendly and home facility design. There are three main points for discuss today. The first one is the definition of anthropometric measurement, and then why anthropometric measurement important for the elderly. And the last one, I will show you previous research application related application of anthropometric data for design. Okay, I'm going to share to begin with what are the anthropometric measurements. Anthropometry is the science of measurement human body dimensions for such as height, width, limb length, or muscle strength, muscle fatigue to apply those measurements to design product and workspace and environments that fit the human body, ensuring the comfort and efficiencies and safety by accommodating physical validation in the prevents for before to strain and injury. For example, in the left side, you can see the human for sittings and number is there are more than 300 anthropometric dimension for the body and to the designs tool or equipment or design to the workplace. For example, in the number 14 and 13, knee height sitting and popliteal height for design the height of chair for appropriate to the human or the user, right? And anthropometry is this slide. I would like to show you two keywords. It means to anthropometry in the system to correcting of the human body measurements from static and economics for design and product fit the people and using anthropometric data for the core components. Number one, you can see more 30 anthropometric dimensions for measurements and especially to important for the design. Number two, for the design, including to the horizontal list and vertical list. Number three, for design, for example, to the desk height, to grip and chair design for functional for the actual user. Now, let's explore why this measurement for the particular important for the elderly. Mismatch between human anthropometric dimensions and workplace, tool or equipment, and device dimensions may be leading to increased discomfort, accident in some tool or equipment if not proper for the body dimension may be result from biomechanical stress, fatigue, and muscle injury among the user. Various accidents such as slip, trip, and fall in the elderly may occur in the elderly population. Previous study found that the most common injury location involved environmental hazard were kitchen, bathroom or toilets, living room, and stair. Therefore, a good anthropometric fit is the essential of the design safe products, home and recreation activities. Particular dose size, shapes, and body composition may be important. I would like to show the importance for the anthropometric for the elderly. For example, to understanding the physical change, reduction and at height and muscle mass in the elderly change. In, for example, to the left side, you can see via measurement for the hand grip strength for determine muscle strength in the women elderly. And the right side, you can see we test maximum voluntary contraction for determine muscle strength and muscle fatigue among the elderly in the women. And when they use to repetitive tasks or repetitive hand, maybe injury. When they use to repetitive and they not appropriate to the some works and not appropriate to the capability and limitations among the in the elderly. The second, safe and accessibility, for example, to the doorways, to furniture heights, bathroom features, must be toilets or physical capability in the older people to prevent accident and enhance mobility. And anthropometry important for health assessment, indicated to issues such as obesity, muscle fatigue, or muscle strength. And the last one, important for ergonomic design, enhance the comfort and usability product in the environment, support the proper posture, and for table that are easy to reach for the older adults. Moving to the next point, I would like to show paper publications related application of anthropometric data for the elderly designs. Figure 1, you can see the mean of status different age group. There are the result review most anthropometric dimension for male are larger than for female. This finding serve up anthropometry value with design application for elderly people. Data for the home and living facility designs can be applied to create elderly friendly environment. Home and living design take into the account target demographic populations. Anthropometry should not be less be applied to ensuring feature, comfort, and safety, health, and equality considered for the elderly. The figure 1 highlights demonstrate trend showing increasing shorter stature with increasing age for both male and female. This result to consistent with previous publication for another country that when the people increasing age, the stature may be shorter. Figure 2 and figure 3, the result for recommendation for the current dimension and risk zone for important for the elderly, because when the elderly may risk more than of risk maybe to accident or muscle injury or muscle fatigue occur. This one you can see to the considering for the height for counter bar or risk zone to appropriate for the elderly in Thai people. Case study 2, I would like to show the study aim to provide anthropometric data for ergonomically designed to impacting elderly farmer. The result review difference between men and women, increasing that men show prominent results. The findings study provide value and anthropometric data in the aging population in Thailand. Implementing anthropometric data for design, farm tool, and designing a safe worker for their workplace, for example, to standing working height in standing position, and for recommendation for single handle tool dimension for the elderly in Thai people. Moreover, this study to comparison between some dimension is the result of the most country 8 dimension for important for the design facility at home or workplace, such as number 1 stature, eye height, shoulder height, elbow height, knuckle height, hand length and hand width, and the grip diameter. It can be observed that older Southeast Asia population have smaller body size compared with European and American population in both male and female difference. And case study 3, designing home the elderly based on the anthropometric data for the older Malaysians. The result, the design of 10 home does not take the anthropometric measurements of the elder into account and maybe therefore cause discomfort. Consideration elderly people should be provided with specially designed facility to meet their physical and cognitive strength, capability, and limitation to match their body dimensions. And the last paper publication for hand support and assist toilet use among the elderly to providing toilets environmental promise and increasing the quality of life of the elderly disabled person. This is one of the goal of the friendly room design. Is what conclude that there is a preferred and vertical support to sitting down and standing up during toilet use of the side support. There were equally appropriate. In my conclusion, anthropometric measurements are essential for creating environmental that they are accessible, safety, and conducive the health and well-being of the elderly individuals. They inform design decisions that enhance usability and promote independence, ultimately improving the quality of life in the other adults. Thank you for your attention.
Thank you very much, Dr. Thirapan. So this is another view that we can do some design to fit with the elder people. So please, we are welcome for the questions and answer. So our speaker are eager to discuss with all of you. Yeah.
May I have one question for Dr. Adison? Yeah, I think it's very interesting about the thing that you develop and modify. I think it's very important now and in the near future because the air pollution is so cause a lot of health problem. Which kind of stage that you go for the commercial or business about this innovation?
Yeah, it's in our pipeline. So now we have already requested the patent, submit the patent application already. And we still, I think that we could, it's in the process as well. And then we have some plan to spin it off and then try to commercialize this kind of products as well. Because right now, I think not only for the research part, so we have a lot of like the let's say the customer for the research project that we many usually try to, but we also have some kind of company or commercials like they try to they're purchasing the kind of sensor for like especially for the government sectors like Obata or municipalities or even though like BMAs as well. So because they try to, because this kind of low cost sensor have been the benefit is that there is a low cost, and then the second one is like, is it portable? Because we can deploy in many places that we like the reference station can be used. Like one example is like in the construction site, or the application that we use is like tracking like the people like on the way. So that kind of the standard equipment that that cannot be used to. So we're on the way to answer that. We are too short. We try on the way to commercialize this product as well.
Thank you so much. We look forward to have one at home. Thank you.
So we still have, so we have question from the chat. Do you share with us about the difficulty when inviting the old adult participation to try those technology? Did you face high dropout rate from them during research? So the question may go to Dr. Jenipat first. I think thinking about the volunteers and like something like dropout rate when then they join and then they refuse the campaign, something like that. Do you face that one? Yeah.
For the dropout, I think we don't have that kind of situation. So mostly we have our team who is like the part of the Department of Disease Control they already have some connection with the elders already. So mostly when they join, they allow us to test throughout the entire project.
Okay, I see. So with the connection of the government sector that they may have the target groups already, and then the people were like very happy to join the campaign. Okay.
Yep.
Okay, thank you.
Thank
you.
you.
I think this question could be relevant also to Dr. Thirapan. So do you try your application with the real situation already or not? And do you face these similar problems?
I think this is can be combined anthropometric data to smart home for with Dr. Jenipat also. For example, to smart home sensor, yes, and maybe combine two, and it better than to be to anthropometric with smart home and sensor technology can significantly enhance safety and reduce risks such as personalized environment adjustment. For example, smart device can adjust height, counter, or position for the furniture, and the placement of essential item based on user list or mobility. Yes, maybe can proper ergonomics and list item that are too high or low, maybe also adjust.
Okay. Thank you. So, what you say that when we can combine the technologies all together to respond on that, and in your opinion, when you have your data, so have you ever applied this kind of data to the real people, or it's just like the criteria of guidelines only?
I think it's the anthropometric to design to the real situations, but in Thailand, the little data for the elderly and maybe out of update for update the data, but we can to update personalized in other adults in both ability change over time. Here are several key points to consider. Update personalized improvement to this update guideline for design elderly friendly home. Yes.
Okay. Thank you very much, Dr. Thirapan. I would say that we thank you very much for our speakers that you to share your valuable research with us, and we see some the perspective in the future, so what we are going to do, and like we move to the more in the society of wireless society or IoT or something, or AI. So I think this is very interested in the near future, and also the good design for the home. And I would like also to thank our participants that joining us today from the beginning until the end of the presentation. Also thank for ACAP and Reinventing University that make this webinar happen. So again, I will say thank you, and we look forward to welcome you to our next episode. And thank you very much for your attention for today.
Yeah, welcome to the today's monthly webinars. Maybe next times, and you will participate in our monthly webinar also. And welcome every times we discuss and share our knowledge and skills with you. Yeah, thank you very much.
Thank you to three speakers to share insightful of your research project, and this is to show how that the young generation have the motivation and idea how to save the environment or promoting the health for the aging society. So this is a good and warm heart, as I'm approached to the elder as well. So this is a great opportunity to learn, and hopefully that we can do something together to have some meaningful project.
Thank you.
Yes.
Bye-bye.
Thank you.
Yes, thank
Bye-bye.
you.
Bye.
Bye-bye.
Happy New Year. Happy
See you.
Christmas.
Happy.
Thank you.